Welcome back for day 2 of our precision and accuracy lesson. Today we're going to talk about relative error. Before we do that, let's read about what accuracy is. So accuracy refers to how close a measured value comes to the actual or desired value. So if you think about this, accuracy, I like to think of like a bullseye. So if I had a bullseye, this would be a target. And then if I had a bullseye, it would be there in the middle, right? So if I'm drawing the target, and then the bullseye is right there in the middle. If I was shooting darts at this board and I hit a dart here, and a dart here, and a dart here, so you can see them, they would not be considered very accurate. If you notice, they're all spread out. Now, if I was throwing darts here and here, if I hit one here, if I hit one here, and I hit one there, those three would be considered accurate, but they would have a high relative error because they're accurate as far as they're clustered together, but they're not accurate as far as where I want them to land. I want them to land near the bullseye. So that would be a high relative error. But if I threw the darts and I had one there, and one there, now we're talking, we have accuracy and a low relative error because they're all within the zone. So that's what we're talking about when we talk about accuracy and relative error. So the relative error of a measure is the ratio of the absolute error to the expected measure. So that means the relative error is you take the absolute error and you divide it by the expected measurement. A measurement with a smaller relative error is said to be more accurate. So let's look at this example. A manufacturer measures the weight of each bag to be 12 ounces. Find the relative error of the measure. The first thing we have to do is we have to find the absolute error. So that's what we did yesterday. Last lesson was you take it, it's rounded to the nearest ounce. So our measure was the nearest 1 ounce. So the absolute error is half of an ounce. So 0.5 ounces. So the relative error is 0.5 ounces divided by the expected measurement, which is 12 ounces. So 0.5 divided by 12 gives us 0.042. But we want to put that as a percent. So we move the decimal 2 places to the right and make it a percent. And it becomes 4.2%. So we're going to look at this example. An architect designs a floor plan for a building. The distance between the bathroom and the conference room is 3.5 meters. Find the relative error of this measurement. Round to the nearest 10th percent. Okay, so we're going to start off with finding our absolute error. So I'll put AE equals. Well, it's to the nearest 1/2 meter, so 1/2 meter times 1/2, because we're finding half of it, so it'd be 1/4 meter. And I'm going to put that as a decimal because it's going to be easier for us to see how this is done. So 0.25 meters. And I'm going to change 3.5 meters to 3.5 meters for this. So our relative error, RE, equals our absolute error, which is 0.25 meters, divided by our actual measurement, which was 3.5 meters. 3.5 meters. So at this point, you would get your calculator out and you would put 0.25 divided by 3.5, and you get this approximately equals 0.071. 0.071. So I want to change that from a decimal to a percent. So I'm just going to move the decimal 2 places to the right. And so we're going to say that this equals 7.1% relative error. And when you do yours, you don't have to write out relative error, just write the percent. So 7.1%. I'm going to do one more problem with you, and then you're going to have the rest of them to do. So I'll do number, let's see, a builder's 42 centimeters, the relative error. 42 centimeters, so that'd be to the nearest 1 centimeter. Okay, I'm going to do number 3 with you guys. So Eamon plants a vegetable garden in his backyard. The length of the garden is 5 1/4 feet wide. Find the relative error of this measurement. Round to the nearest 10%. So the first thing I'm going to do, just like last time, we're going to find our absolute error first. Absolute error equals, well, they're rounding to the nearest 1/4 foot, so we're going to say 1/4 foot times 1/2, which gives us our absolute error is to the nearest 1/8 feet. Now I'm gonna do this as a decimal because when we do the relative error, it's going to be easier to do them when they're in decimal form. So 1/8 as a decimal equals 0.125, and then feet was our unit, and 5 1/4 is 5.25 feet. So relative error takes our absolute error divided by our expected measurement. So I'll just put expected measurement. So our absolute error was 0.125 feet divided by our expected measurement was 5 1/4, which we said is 5.25 feet. 5.25 feet. So you notice our units cancel, and we get 0.125 divided by 5.25, and I get approximately, so this approximately equals, and I say approximately because we're rounding at some point, so 0.024. And then when I move that to a decimal, from a decimal to a percent, I'm just going to move the decimal 2 places to the right. So this equals 2.4%. And that's our answer. 2.4%. So you guys have 2 problems to do. You have number 4 and number 2. I already did number 1 and number 3 for you guys. So watching the video really helps. All right, guys, have a good day.